Hello there. We have an interesting question here which involves two lines having their own equation, and also it involves a little bit of geometry in terms of area of a triangle. Okay, the question is that f of x passes through the point A 1, 3. A is here, which is 1, 3. Again, g of x crosses the y-axis at point B. So g of x crosses the y-axis at point B. We know it is just as x is 0 and y is 6 from the graph itself here. But we will verify mathematically this part. The other one, f of x and g of x intersect at point C. C is the intersection point here. Again, we can see C is as 2, 5. This is what we see graphically. But again, we need to verify the exact value of that. Once we know this, we are asked to find the area of the triangle here, A, B, and C. A triangle ABC. We need to find this area. That's the question. Let's do now step by step. What is point C? When we have two graphs in which they have an intersection part, then we can simply solve this simultaneous equation on these two lines to find out what common x value they have. Let's do that. Before we do that, we're not given g of x directly. We're given here as 2g of x plus x is equal to 12. Again, we need to put g of x in its exact term. G of x means y, in other words. Let's do this part first. 2g of x plus x is equal to 12. 2g of x is equal to minus x plus 12. G of x is equal to minus 1 over 2x. I have to divide these two for both x and 12. Then 12 divided by 2 is 6. So g of x as a function named g of x, or we can simply call it also y is equal to minus 1 over 2x plus 6. This is the other equation for the line. We can call it L2 or the other line. Now we have two equations. The other one here, f of x is equal to 2x plus 1. Let's equate these two graphs and see what's the common point C in here. Here, 2x plus 1, which is f of x, is equal to, here we have g of x minus 1 over 2x plus 6. This will help us to solve the value of x. Once we have the value of x, we can put that into any one of the two to find out the corresponding y value. Because they intersect at this point, then they must have equal y values and equal x values, in fact. Okay, let's complete this part. 2x minus half x is equal to 6 minus 1. I'm moving minus half x this way. It changes the sign up here. I'm moving 1 this way. It changes the sign. Okay? 2x plus half x is, when we give it a common denominator here, 2x means 4x over 2. When we have a common denominator this side, we have 4 plus, to make things clear here, 5x, which is going to be 5 over 2x, this part. So 5 over 2x is equal to 5. 5x is equal to, I take that part, 2 times 5. Then x is equal to, I divide both sides by 5, then 2. Now I have the value of x, which is 2. Good, the graph also agrees with that. That's one thing. Now let's find out the corresponding y value by putting 2 in any of the two equations. Let's put it here to the f of x. F of x is equal to 2x plus 1. Then 2 times 2 plus 1 is 5. 5. Very good. Now we have this one. Let's find out the y-intercept of g of x this side to find out the corresponding pointers or the point in here. That is from the general form of y is equal to mx plus b for a linear equation. B is the y-intercept. X value 0, y value b. In this case 0, 6 for g of x. I have this covered in other parts of my channel. You can go and have a look into that if you need more. So this is going to be here 0, 6. Okay. Now we have the 3 pointers of this triangle. The next thing is we need to use a distance formula to find the distance between this one and this one. This is much simpler method than anything else. Let me find out the distance A here first. Distance A here, you can see this distance as, let me trace something here to make things clear. You can see this triangle here, which is a right angle triangle, in which it has got 2 sides here and then a hypotenuse. So we can use a Pythagorean theorem to say a square plus b square is equal to c square form. That is how it is. In other words, this part, the vertical part, is having a common x value, which is always 2 here. The horizontal part will have a common y value, which is 3. These two are the same here, 3 and 3. These two are the same. So we can use a Pythagoras theorem. How much is this vertical part? So just to make things clear, let's just see the difference of the y values, 5 and 3, which is 2 here. Okay. How much is the x value here? The difference of the x value. Y is constant on this side. X is 1 here. Then by Pythagoras theorem, what is the hypotenuse for this triangle? Which is hypotenuse is equal to square root of a square plus b square, right? Which is square root of 1 plus 2 square is 4, which is root 5. We have root 5 here. Likewise, we can do the same for the other one here. This side is also root 5. Now we have 2 sides of a right angle triangle. And then what is the area for a right angle triangle with 2 sides A and B? Area is equal to half of A times B. In our case here, this is an isosceles triangle in which 2 sides are the same. Okay, both are root 5. So 1 over 2 times root 5 times root 5. Root 5 times root 5 is just 5. We still have 1 over 2 times 5. So the answer is A. Thank you for watching.